So, um, thank you very much to the organizers for having me here. As everybody, it's a huge pleasure to be in this place with this audience. I'm going to talk to you a little bit about what we've been working on for the past 3 years to put together a quantum initiative in São Paulo and Brazil and, well, Latin America, but I'm not going to talk about Latin America today, so I'm sorry. I apologize for that. I've been to a few conferences, and people like Peter Zoller came up to me and asked, why isn't there a quantum initiative in Brazil? Now, he asked me that right in the middle of our previous federal government, which made things very hard, but we thought in the state of Sao Paulo we stood a chance. So I want to tell you a little bit about the efforts that we've been doing to put that together. We've all heard here, okay, at this wonderful workshop about the ingredients that come into this new revolution in quantum sciences and technologies, uncertainty relations, no cloning, and help for security, superposition, entanglement, indistinguishability, which give us abilities to process and store information, environment-induced decoherence and disentanglement, as Louise told us about, which is very interesting for sensing. Now, a few years ago, you may have seen this special number of The Economist on quantum leaps. There's one sentence that really stuck with me. This was in 2017, so 6 years ago. The community thought the odds are good, but the goods are odd. We've seen this picture already before, and Carl made some comments about the numbers related to China, for instance. It's clear that there's a huge effort worldwide in terms of economic value of quantum information technologies. And you can see that in the latest version, 22-23, Brazil, which was gray on the picture, suddenly showed up with an effort of equivalent to $12 million. Not our best effort. I don't really want to get too much into that, but there are other things going on now. So yesterday, we also heard about the importance of having societal concerns and having more equanimous development. That's not true of everything. So I went to a meeting in Delft this year, and I saw this on a desk. So are you aware of export controls in the quantum domain, which means that these technologies will not be available to everybody? I think we have good reasons to have a quantum strategy in Brazil. So the people involved in this effort, Senhor Viana Borges, Celso Vilas Boas, who spoke yesterday, Frederico Brito, Gustavo Wiederhecker, Marcelo Terra Cunha, myself, and Philippe Cortei. You may notice, I don't think it's by chance that out of 7 people, 4 are from São Carlos. We have a pioneer there who has been developing quantum optics, atomic physics, optical physics in general, and I think this shows on this effort. So we have an international committee, and we were very fortunate to have in February in Brazil 3 people who are in this picture. Philippe Bouillet, a little different at the time of this picture. Cristiani, sitting right next to me, whose talk is really hard to follow. And Arthur Eckert, who is here in the audience as well. Louise, so 4 people. I'm sorry, Louise, you're local, so 4 people. We actually, I have another picture, but I'm not showing today. You should come to these workshops in Brazil. We went to a restaurant with very nice caipirinha, so you're all more than welcome to develop these things in Brazil with us. So we've set up a flyer. We obviously connect our efforts to the Sustainable Development Goals. There are lots of interesting applications that can come from this. Main issues focus, build on our strengths, enhance our quantum technology R&D strengths, focus on viable technologies, capabilities, collaboration. This is all about a collaborative effort, and readiness. And I think the first part of the readiness is really to educate a quantum workforce. We've heard here also that this is not an issue that applies only to Brazil, but it's definitely a very important issue for us in Brazil. Now, in my current capacity, I've been, so I'm a physicist myself, specialized in quantum optics. And now I say that I'm also an apprentice in the fundamentals of innovation. And this is a framework that has been put forth by a group of people at MIT, which I think is extremely important to understand in order to shape public policy. Now, all of this talk may seem to you quite applied, and I'm going to say something I've heard from Ed Hines at a conference before. Even though this may seem to all of you very applied, I want to vouch here that I myself remain pure at heart. The important thing in this structure is that in order to to drive a successful ecosystem, innovation ecosystem, this structure essentially appears everywhere. And it's built on foundational institutions, which are basically the things that don't change so much. So rule of law, preferably no corruption, ease of economic fostering development. On top of that, there are two capacities, an innovation capacity and an entrepreneurial capacity, which are not the same and which feed into each other. And can help us take advantage of comparative advantages that we can have in a certain region. I'll expand on that. And on top of everything is impact, which is the objective, is the goal of innovation. So why should we go after an effort to have a quantum initiative in Brazil? Well, I think this is the reason why Peter came up to me and said, how come there is no quantum initiative in Brazil? As Luis has mentioned, we have National Institutes for Science and Technology. These started actually with Millennium Institute projects, bringing together a community in AMO physics, but also in condensed matter physics and computer science, math, and which, as you can see, is now spread out in almost all the regions in Brazil. So the only region that is missing on this map is the northern region in Brazil. But we have a few efforts in the center west. We have strong efforts in the northeast. We have obviously preponderance in the southeast, and we have important groups in the southern part of the country. What are we good at? Well, spontaneous parametric down conversion, both theory and experiment, especially the group in Minas Gerais pioneered this, and then in Rio de Janeiro, they were very strong. The group in Rio de Janeiro, unfortunately, the main experimentalists left Rio de Janeiro. One of them is still in our country, Paulo Henrique Souto Ribeiro, who is in Santa Catarina, but Steve Walborn, a huge driving force, is still in Latin America, so that's the Latin American part that I'm not going to talk about. He went to Chile. Cold atoms, VC, atom interferometry, São Carlos, Recife, very strong places, Campinas. Optical parametric oscillators, continuous variable entanglement. Well, we play a modest role in that in our lab back in São Paulo. Quantum thermodynamics, of which we heard a beautiful talk this morning, mainly using NMR systems, quantum algorithms. We have an initial effort in superconducting qubits in Campinas, and we can go on. So we have the academic strength. We understand the subject. We have the scientists who can train people. We don't have the technological aspect. We're not being able to turn this science into meaningful technology, and this is what we really have to concentrate on. A few more or less recent highlights. So continuous variable entanglement, experimental work, contextuality, non-locality, photon correlations, maximal demons, quantum thermodynamics. We have some technological efforts in optomechanics, in Campinas, structured light in different places in the country, and encoding information into this structured light. A very recent effort, and Celso already spoke a little bit about this, is geared towards quantum communications. So there's now the beginning of a Rio quantum network with these institutions, Fluminense Federal University, Antônio Zelaquete Cury, Catholic University in Rio, where I was an undergraduate student and a master's student under the supervision of Luiz, the Brazilian Center for Physics, and the Federal University of Rio de Janeiro. And this is what it looks like. They intend to have the three universities in Rio connected by fiber optics and in free space connection from CBPF to the Fluminense Federal University across the bay. I'm not even prepared to tell you a lot more details, but this is a very interesting proposal with a Sagnac type geometry for the quantum communication process. Our military has developed an interest in quantum information technologies, and the cyber defense is now promoting workshops and getting together with the scientific community in order to push this forward. So from that issue in The Economist, there's wisdom that for me is very influential from Sir Peter Knight about the difficulty of building these exquisite quantum machines. And as Luiz told us yesterday about the sensitivity in the interaction with the environment, the day before yesterday, sensitivity in the interaction with the environment, how quantum correlations are fragile. Not only quantum coherence can decay exponentially, but entanglement can vanish in a finite time. Or in the case of continuous variable systems, we prove that you can lose completely entanglement after finite propagation in a lossy medium, whereas squeezing, for instance, which is our resource, would survive for infinite propagation. So as Peter Knight said, we turn it on its head. If the system's coupled to the outside world so effectively, they're sensing the outside world really effectively. And so this is kind of a defect in building quantum computers, which lead to building better sensors. And this is something which we think is the best shot for our initial efforts in these technologies. I came across, so I heard from a friend who there were people developing quantum sensors for agriculture. I came across this sentence, quantum tech, one of 6 inventions that will transform farming. And as I told you in that structure for fostering an innovation ecosystem, one of the things that we have to look into is comparative advantage, right? So it turns out that when we look at Brazil, it's the 3rd largest global agribusiness exporter nowadays, over 100 million hectares available for agricultural expansion without further deforestation. If we look at FAO reports, and we look at the prospect for growth in the agribusiness sector in the world, Brazil clearly has the largest potential there. So with all this potential, Brazil could respond for 40% of the global additional food demand expected for 2050. Now, this is a challenge for all of us. The FAO expects us to need to increase in 50% the food production today until 2050. And Brazil could respond for 40% of that. What that means, in my view, is that science or agribusiness has to be focused on Brazil. And again, in innovation, this is a local effort. So this science has to be developed locally. And again, sensors for this are something in which we can lead. We can not just jump in and follow a wave, but Brazil has the potential to lead. So obviously I went to look at the literature and I found this paper with this very nice title, Quantum-Based Agriculture, the Final Frontier. But then I read the abstract, and the abstract talks about intuitive farming incorporating the use of telepathic interspecies communication. Um, well, you know, we heard also that in order to build innovation ecosystems and drive investments, we need hype. There should be a limit to that. So we really need to increase public awareness of quantum. Speaking of something which is not hype, Embrapa is a very nice company in Brazil. Long history of producing technology for the agribusiness sector. And here is Deborah Milori, again, Vanderlei's former student, who leads an effort at Embrapa, and she developed a technique called LIBS, laser-induced breakdown spectroscopy, applied to the agribusiness sector. And in this company, they analyze the carbon content in soil using laser spectroscopy. Now, the usual techniques, chemistry-based, companies can analyze about 900 samples per month. In agrorobotica, using this technique, they analyze 1,200 samples a day. So there's a lot of promise in this sector. These are companies that have been working together with us for the development of this roadmap and with whom we expect to work together in agriculture, computing, communications, education, engineering, and health. Now, I told you about this picture for fostering an ecosystem, and the Deputy Provost for Innovation looked at this. If we look at the ICAP and ECAP, they have 5 resources each. They're the same: human capital, funding, infrastructure, demand, culture, and incentive. But when we look at them, you're not going to be able to read, but the input for innovation capacity is not the same as the input for entrepreneurial capacity. Human capital, building a quantum workforce is definitely important. It's a multidisciplinary effort. As we heard from John Martinez, I'm definitely convinced that physicists won't do this alone. We need engineers to develop technology, but we need engineers who understand quantum technologies. And our strategy is, well, let's learn about quantum computing from its defects. So let's train these people building useful quantum sensors. So I'm very optimistic that a new program on quantum information technologies, after 3 years of us working on this, will be approved on December 13 with the prospect of giving $20 million for the state of São Paulo. And this will give rise to our program on information on, so in Portuguese it's inverted, so it's going to be PIQUAL, PyQuant. And just to leave you with this message, Raul Gonzalez, the Deputy Provost for Innovation at the University of São Paulo, compared this to a control system. We have 10 actuators. That's where we can play, we can tweak the system. And so with these actuators and control theory, eventually we can steer this into a positive result. And obviously I don't have to tell this audience about control theory and its abilities, but I do want to show you what our engineers at the university can do. And we also saw before what we can do with waves in a pool. So let me just leave you with this. So we can play with rather complex systems. And so this is what they're doing. If you look at the yellow actuators, they're moving, and they can do a constructive interference. And there you go. You have something really nice that can be done. And with that, I thank you for your attention.